We'll have another example of the problem that we had on our last test. We're going to look again at chemical equations, how to make a mole. We're going to calculate the number of moles and the number of grams of product. So if you remember the magnesium example that we had on our last test, you'll probably have another one like that on your next test. Let's look at another application of this. Okay, so I want to write a balanced equation for 1 mole of methane plus 2 moles of diatomic oxygen yields 1 mole of carbon dioxide plus water. Now, this may not sound like much, but let's look at what this is. Okay, so if you've ever driven by a refinery or a factory or anything else, and it's got a big old pipe coming up, and there's a fire burning constantly outside of this pipe, and this fire just burns constantly. Okay, that's what this reaction is. We're burning off excess methane into the atmosphere. All right. So really an important example, because we want to get rid of the methane. We don't want the methane to go up into the atmosphere. Okay. So what we're doing is it says write this balanced equation. So let's look at this. So the balanced equation is given to us in the problem. All right. So 1 mole of methane plus 2 moles of diatomic oxygen. Okay, so methane, CH4, 1 mole, no number out in front, 1 mole of methane. Okay, so we've got that covered. Okay, so there's our 1 mole of methane. Plus, okay, 2 moles. All right, so here's our 2 moles of what? Diatomic oxygen, O2. So now this is where we're putting in our equation. This is where we do a subscript. It tells us to use diatomic oxygen. Okay. What does it yield? Okay, 1 mole of carbon dioxide. Okay, so 1 mole of CO2. All right, and then plus. Actually, really, this will actually give you this plus. Oh no, here we go. No, I'm sorry, I got ahead of myself. Plus water. Don't balance it yet. Okay, so it's gonna. So this is what your problem will say. Okay, 2 moles of diatomic oxygen and 1 mole of methane yields 1 mole of carbon dioxide. It says plus water. So does it tell you how many moles yet? So now we've got to come back and balance that. Okay. So once again, it's exactly like the magnesium and the oxygen example, except now with a different application. So let's balance that. Okay. So how many carbons do we have? We have 1 here. How many carbons here? We have 1. Okay. How many hydrogens do we have here? We have 4. Okay. How many hydrogens do we have here? We have 2. We can fix that. We can put a 2 here. Remember, balancing chemical equations, you can change the number of moles, but you can't change the subscripts. So now, how many carbons? 1, we're still good. How many hydrogens? There's 4 here. How many hydrogens here? There's 4. Okay. Now, all right, now let's take a look. How many oxygens do we have here? Okay. How many oxygens do we have here? We have 4. Well, let's look over here. How many oxygens do we have in the whole product? Well, we have 2 oxygens here, and we have 2 here because that's 2 moles, which means 2 water molecules. So we're balanced. So we actually have 4 oxygens here, and we have 4 oxygens here. So now we're balanced. Okay, so now we're balanced. So now then, if you remember in our sequence of progression, the next one says how many moles are present, but it's got to tell us how many grams of each thing. Okay, so now I want to know how many moles are present if 15 grams of methane and 10 grams of diatomic oxygen are present. Now, remember to calculate moles, all right? Remember, moles are equal to, okay, the number of grams times 1 over the gram molecular mass, okay? So let's do that. So we want to calculate, first of all, how many moles of methane. Okay, well, we got to come up here and it tells us that there's 15 grams of methane. So 15 grams, okay, of methane. Okay, now what's the gram molecular mass of methane? Well, carbon is 12. We're getting this off our periodic table. Carbon is 12. Hydrogen is 1, but there's 4 of them. So 1 times 4 is 4. So 12 plus 4, we're going to get 16. Once again, total molecular mass of methane is 16. So then we put that together. So we take 15 divided by 16, and we get 0.94 moles of methane. Cool. Now, we want to know how many, because what are we doing? We're figuring all the moles of everything in our reactants. Okay? So here we go, we did good here. Now we want to know, all right, if 10 grams of diatomic oxygen are present. 10 grams of diatomic oxygen. Okay, well, that's good. Okay, so here's 10 grams, okay, of diatomic oxygen. Now, that's going to be that's going to be multiply, or that's going to be, we're going to take the grams. Okay, once again, moles is equal to grams times 1 over the gram molecular mass. So it's a gram molecular mass of what? What does it tell us here? Okay, diatomic oxygen. So that's O2. Each oxygen is 16 times 2 is 32. So we have 10, okay, divided by 32 is 0.31 moles of O2. Now, what's the limiting factor? Well, the limiting factor is going to be the one with the least. So we look at 0.31 is less than 0.94, which means that the limiting factor is O2. Now, why is that significant? That's a good thing. That's a good thing. That means this methane is going to keep burning as long as we have oxygen. But what's nice is we have a lot of oxygen in the air. We can keep producing the oxygen. If oxygen is a limiting factor, that's wonderful because we can keep reintroducing oxygen from the air. What if methane was a limiting factor? Then when we ran out of methane, the flame would go out. The flame would go out, we would have to relight that flame all the time. This is a classic chemical equation here, classic chemical problem. This flame burns forever because as long as there's methane, there's always O2. All right. Now, we want to know how many grams of product. Now, this is the other thing. It's like, what are we putting off into the atmosphere? What's environmentally safe here? So let's figure out how much product we have. So now, how do we do the grams of product? Thinking back about our original example of the magnesium and the oxygen. Well, we have to add up the number of moles. Okay, we have to add up the number of moles. So these are the moles in the reactants. We have 0.94 moles of methane and 0.31 moles of diatomic oxygen. We add those together and we get 1.25 moles of reactants. Oh, cool. Now, we multiply that times 1 over the gram molecular mass of what? All of the products. The gram molecular mass of all the products. So let's see what that's going to be, okay? Carbon is 12. You'll get to where you're pretty good. You can always use the periodic table, but certain ones like carbon being 12, oxygen being 16, and hydrogen being 1, you get used to those. The most common elements in chemistry is carbon, hydrogen, and oxygen. So carbon is 12, that's good, okay. Oxygen is 16, but we have 2 of them, so 16 times 2 is 32. But the reason why I want to give you this example is because we have more than one product. So now this is where the balancing numbers come together. So now I've got to calculate here. I've got to say, okay, how many hydrogens do I have? Well, I have 2 H2Os, so I have 4 hydrogens, okay. All right, so I have 4 hydrogens. Hydrogen is 1, okay, so 1 times 4, okay, is going to be 4. All right, now how many oxygens do I have? I have 2. Each oxygen is 16, so 16 times 2 is 32. So when I add those together, 12 plus 32 plus 4 plus 32, I get 80. So that's where I get my total, that's where I get the gram molecular mass of the product. Okay. Now, once again, plug these in, keep practicing, you'll get pretty good at these. So, the total moles of the reactants, 1.25 moles of the reactants, times 1 over 80 is going to equal 0.02 grams of product. Now, this is pretty cool, okay? This is pretty cool because what happens here in this flame is it's really neat because 0.02 grams of product, we have to say how much of it is carbon dioxide, how much of it is water. And the amazing thing is that we put very little carbon dioxide in the atmosphere from this flame. So it's really a cool deal. So most of what's given off is water. Well, what a cool deal that we're putting water vapor out into the air. That makes a healthy environment and gets rid of methane, which is a poisonous gas. So it's a win-win. Great example for chemistry. So once again, this type of problem looks difficult, but if you'll learn it step by step, it's pretty easy. Once again, we've got a balance equation. Then we've got to calculate the number of moles. Moles are equal to the grams times 1 over the gram molecular mass. And then when we do the product, then we have to add up the moles of everything in the reactants, okay? And then we divide that by the gram molecular mass of the total product. So, we're going to end that on a crazy math problem, but I want you to keep practicing those. You'll have a couple more of those on your next test. See you next video.